Hi everyone, my name is ECCLISIA. My register number is URK23CS1120. Today we are going to see the seventh experiment, which is performance analysis on KNN classification techniques. Let's move on to the question part. The first question is to read the data from the wine dataset CSV file. Let's move on to the coding part. In this, first we are going to import pandas, then we are importing numpy, and uh, next we are going to read out the CSV file, which is wine-y.csv file. Then we are going to print the first five rows. So we are using .h command to print the first five rows of the data set. Second question is to cleaning the data. So inside that, there are three questions. The first question is to replace the zero value into NaN values, and the second is identify the column with null values. Then third is filling the null values by imputing the mean values in the corresponding column. Here, the first question we are going to do is just replacing the zero values for these columns, which is chlorides density and pH and sulfides. So we are using replace command to replace the 0 to NaN, and we are going to print the first five rows of the data set. Second question is to identify the missing values, then we have to print it. So we are using SNull value and dot sum. We have to print all the values. So we are using the isNull and sum command. Third is we need to fill the missing value with mean of that column. So we are using fillNav command and isNull and sum to print all the missing to fill all the missing values with mean of that column. Next question is about to use the column fixed acidity, volatile acidity, citric acidity, residual acid, sugar, chlorides, free sulfur dioxide as the independent variable. Here we are choosing these columns as X. The columns are fixed acidity, volatile acidity, citric acid, residual sugar, and chlorides and free sulfur dioxide. And we are just printing that X value. So we are using head of command and printing the first five rows of the columns. And next question is use a target value as quantity. So good and bad based on the score greater than 5 and less than 5. When it is greater than 5, we need to print the good. When it is less than 5, we need to print bad. So let's move on to the code. Here we are going to convert the quality into categorical label. So we are going to find out which is greater than 5 and which is less than 5. In the first, then we are printing the first 10 rows of the data set. So here in the first 10 data of the data set, everything is less than 5. So everything is printed as bad. The next question is encode the categorical value of the target column to numerical column. Here we are going to consider label encounter of A as LE. Then we are uh, going to define DFS of quality encounter equal to LE dot fit and underscore transform. Then we are going to print the label encountered mapping, which is bad is 0. Is declared as 0. Then we are going to print the first 10 rows with encoding values. So we are including quality and quality label and quality encountered to print in the output. Then we are using head of command to print the first 10 rows of the call data set. Then the next question is to divide the data into training 75% and testing set as 25%. Here we are using the same as we use in previous question, which is fixed acidity, volatile acidity, citric acidity, residual sugar, chlorides, and free sulfur dioxide as X, then quality encoded as Y. So we are going to identify for extend shape, X test shape, Y train shape, then Y test shape. So we are using shape of dot shape command to identify all the values. Next is about to perform the classification with k equal to 3. Here we are going to initialize that knn with n underscore neighbors equal to 3, which is given in the question. Then we are fitting the x train and y train. Then we are considering the and we are going to predict the y as knn dot predict of x underscore test. Then we are printing the predicted labels for first 20 columns. Then we are going to print the accuracy using the dot score value of the x test and the y test. Next question. We are going to analyze the performance of the classifier with various performance measures and displays such as confusion matrix, accuracy, recall, precision, specificity, F-force, receiver operating characteristics, ROC, curve, and area under curve AUC score. We are going to analyze the given performance. So we are using CM, which is confusion matrix. Then accuracy we are using. Then we are using recall, precision, and F1. F1 means here F source is the F1 which we are using. Then if length of KNN and dot classes is greater than 1, then we need to print the AUC. Otherwise, we need to print the AUC dot float of NAN. So here is the output. Then we are printing the confusion matrix and the accuracy, recall, precision, and F1 and AUC values. And next question is to change the value of k in KNN with 5, 7, 9, 11 and tabulate the various TP, TN, accuracy, FOs and AUC score obtained. We need to fill in that tabular column. So we are using the first we are using the empty list. Then inside we are using the for loop for k in 3, 5, 7, 9 and 11. Then we are using KNN equal to k neighbors classifiers, which we don't know the value of k, so we are using the value as k. Then we are using fit of command. Then we are using y predict. uh, then we are using cm and tp tn accuracy f1. As the previous question, we are going to calculate all the value using if and if else. Then we are using append for the six six given questions. Then we are going to print the values in the tabulated form. In the last question, we are going to analyze and infer for which k value the classification algorithm provides better performance. We are going to find which is considered and which is performed in betterest way. So we are using uh, IDX max to find the betterest way. So at the last, we are going to print the best k value, and here's the answer and the output. Thank you.